I know, didn't everybody just forget about it? But it's so easy to record with that. Okay, we'll wait for Gabby to get back. Okay. All right, so listen up. I know that some of us have a little bit of homework that they need to catch up on.
Yeah.
So the plan for today is we're gonna do notes. Okay, which this you have seen before, shouldn't be anything too difficult. We're gonna add, subtract, and multiply polynomials. And then you do not have a new delta math because you have a review that's on paper today. Okay, so you're not gonna find another assignment on delta math. You're gonna have a test review that's on paper. We'll take our test on there. Okay? All right, so take a look at the top for me, please. Okay, are we ready? Let's put computers, just shut them for now. This shouldn't take us too long. Okay, when you are adding and subtracting, okay, here you go. All right, when you are adding and subtracting, you can only combine coefficients of like terms. Okay, and so what I mean by like terms is that they have to both have the same x piece for you to add them or subtract them. Okay, then it says when subtracting, use distribution to distribute the subtraction. So let me show you what that means. Okay, for the first example, you are only looking for x's of the same type to add together. So if I have a 3x cubed plus, what is my other x cubed that can go with it? Okay, and then you only add the numbers in the front. So in that case, it'd be 3x cubed plus 2 more x cubed makes how many?
5x cubed.
5x cubed, very good. Okay, then I would go to my second term, which is a 7x squared plus, and then I would look through here for another x squared. Do I have another one?
No.
Then the 7x squared just stays by itself. Okay, then for my next term, I see that I have a plus 9. That is a number with no x. Then I'm going to add it with any other numbers that have no x. What else has no x?
10.
The 10, and 9 plus 10 is?
19.
Leave a little bit of space, put a plus 19. Okay, then I notice that the only thing I haven't added is this regular x, but there has to be another regular x for it to go with. Is there one?
No.
Then I would just keep that term the same. So my minus x would stay just like this. Okay, you cannot add the 5 and the 7 together because they have different x's with them. This is an x cubed, that's an x squared, then they can't go together, you're done. Okay, for your answer, you are going to list it in what's called standard form. You'll see it down here. Okay, standard form is just where you go from highest to lowest power or degree. Okay, you want to go from highest to lowest. So we already wrote our answer like that, but let's just observe that it goes x3, then x2, then x, then just a number. Good? Okay, let's do number 2. At the top right here, it says, if you are subtracting, you need to distribute the subtraction into the parentheses. So what that means is my first parentheses is going to stay exactly the same. So I'm going to have a minus 2. Okay, minus 2x cubed plus x squared minus 4x plus 1. Because this isn't the term we're subtracting. This one doesn't have anything in front of the parentheses. Okay, but then as soon as I see that minus, I don't have to do this with plus, but as soon as I see a subtraction, that subtraction is going to apply to everything in that parentheses. So my 2x cubed is now a minus 2x cubed or negative, correct? When I minus on another minus, that turns it to a? Okay, good. And then minus times 4 is now a minus 4. Okay, then once you have distributed, you're gonna do the same thing we just did, look for the like terms, add them together. So I see that I have a negative 2x cubed and another negative 2x cubed. Can those cross out?
Yes.
Not if they're both negative. If you borrow $2 from me and then you borrow 2 more, are we good? No, now you owe me 4. Before we're fighting. Okay, negative 4x cubed is correct. Next term, I have a plus x squared. Are there any other x squareds? There is? Nope. X squared is gonna stay by itself. Because there's nothing else with the same x2 on it for it to go with. Okay, then my next term, I have a minus 4x, and I'm looking for another x. Is there one? What number goes here if nothing's there? 1. Okay, so now let's go back to the example. You owe me $4 because it's negative, but then you pay me back 1. Negative 3x. Very good. Okay, and then for the last term here, we have a plus 1 and a minus 4. That would also be minus 3. Okay. Minus 3. Do you guys want to get calculators or are you fine with? You're just adding, subtracting, multiplying. If you want to go get one, maybe get one for a friend. I'll give you a second to do that, okay? So go grab one if you want one. Okay, so we all have calculators if we want, and let's go to the next example. Do you see? Okay, do you see where it says f plus g of x? Okay, I want you to basically just apply the x to both of those. They want f of x plus g of x. Okay, so if they put the f plus g together, they're just telling you to add them. Okay, where your formula, this just means you're going to have x's in your answer. So my f of x formula is this guy right here. Okay, I'm going to write it out since it's your notes. Okay, but you don't have to write it out if you can add it in your head. So it'd be 5x4, 10x3, minus 9x2 plus 15. Okay, and all of that is your f formula. And then I'm going to put my plus, and then I'm going to copy down what my g formula is. So my g formula is kind of short, thankfully. It's just an x3 minus 2x2. Now, quick question. Do I need to distribute this plus? No. You could, but it won't change anything. Only if it's a minus, do you have to push it into each term. Okay? So, do I have another x4 to go with the first 5x4? No, keep it the same. That one's alone. Do I have another x3 to go with the 10x3? How many? That's a 1x3, and 10 plus 1 more makes 11x3. Okay, next term, I have a minus 9x squared and a minus 2x squared. You borrow $9 from me, and then you borrow 2 more. How much do you owe me now?
11.
Minus 11x squared. Okay, and then anything else we need to include?
15.
Don't forget the plus 15. Very good. Okay, and even though the plus 15 doesn't have another number to go with, you still need to put it. Good? Okay, for the next one, what will I have to do on number 4 that I did not have to do on number 3? Distribute the negative. Very good. So for my first term, I'm going to put a little divider here. I'm going to copy my formula for f. This is f of x minus g of x. And then I'm going to copy my formulas. So f was a 5x4 and x3. 9x2 plus 15 minus. And then when I put my G formula, I know I'm gonna have to distribute. You're gonna need to put parentheses around that or push the negative into both terms. So I'm gonna put parentheses first, x3 minus 2x squared, and then we'll do this guy. Okay? So I don't need to do that with addition, but I do when it comes to subtraction. Okay, from here, I'm gonna be a little bit lazy and just put that all of this is gonna stay the same. But it's just this second part that's gonna change. I'm gonna have a minus on my x3. And what will I have on my minus 2x? Now it's a plus. Because remember, a minus on another minus makes it a plus. So then now we're gonna combine like terms between all of these guys and these guys. Okay, look for your ones that go together. I only see one x to the 4, so 5x to the 4 is gonna stay by itself. Tell me what my x cubed terms are. What are the numbers in the front? I have a 10 and a what? Minus 1. What's 10 minus 1? 9x3. Okay, then I have a negative 9 here and plus 2. You owe me $9 and you pay me back 2. Now you owe me 7 and then plus 15. Okay, do you remember how to add and subtract like terms? Okay, the only other operation we have to talk about is how to multiply them, okay? So come down here to multiplying polynomials. Okay, we'll learn how to divide these, but not for this test. Okay, adding and subtracting, they have to be the same type or you can't do it. Multiplying, you can multiply any terms. Okay, but you're only gonna multiply the numbers in the front with each other. And then you're gonna add the exponents together. Okay, you're gonna multiply the numbers in the front and then add the exponents together. So if you take a look at your first example, this is 3x3 times 7x2. It doesn't matter, they're not the same type, because I'm multiplying. What is 3 times 7?
21.
21 is correct. And then I'm gonna add the little numbers up top to see how many there are all together. I have 3 here, 2 more here, that'd be x to the 5.
Yeah.
Very good. Yes, ma'am, that is correct. Okay, take a look at your second one. I have 8x times 7x squared. What is 8 times the 7?
56.
56. Now, when I add the numbers up top, okay, this x doesn't have a number up top, then how many does it count as?
2.
1, and then 2 more?
3.
x3, very good. Okay, it should be x to the 3, because remember, this little x here, okay, is really an x1. Okay, last one like that, do number 5 for me. Hello? Yes. I do, but she's not been here a few days. She left her house key here. Oh, okay. Well, I guess if it's her parent, let him know that she's not come to. I haven't seen her since last week. Okay, thanks. Bye. Okay. Last one, no number in front. What number is it? 1. What about no number up top? 1. So I'm gonna do 1 times 2 in front is 2. And then x and x5 makes x6. Okay, turn the page. Okay, we're not gonna do all of these. We're just gonna do maybe a couple more examples to make sure you get it. Okay, if you will, please, let's take a look at number 6. Do you see that you have a number that is in front of a set of parentheses? Just like the negative, you're gonna distribute that into each term. So remember, when I multiply, the numbers go together and then the little numbers add together. Okay, so look at the first one. What is 3 times 5? And then how many x's will there be if I already had 3 and now I'm bringing in 2 more? X5, very good. So it'll be 15 for your coefficient, x5. Okay, next term. Still a 3x squared times by a negative x squared. There's a 1 in front, remember. So what is 3 times negative 1? Negative 3. And then I already had x2 and another x2 makes x4. Very good. Next one is going to be 3x squared times negative 4x. What will the coefficient be? That is an exponent. Yes, correct. Negative 12 I heard was correct. How many x's? 3 is correct. Because remember, his x counts as 1. So if I bring in 2 more, that'd be x3. Okay, last one. We're doing times a plus 2. What is 3x squared times plus 2? 3 times 2 is 6. No more x's to add in, then I just still have the original 2 that were on the outside.
They don't know that they'll always like it never skips one. They're always.
No, you may have to times it in, and then if they're not already in order, just rewrite it in order.
But like it'll always include all the numbers.
You could have some that skip.
Okay.
Okay, let's go down for me, please, to number 8. Okay, this is called double distribution. Okay, if you'll label numbers 8 and 9, you're gonna have to do what's called double distributing. And the reason that it's called double is because I don't just have one number in the front, I actually have 2 things in the front. So here's what you're gonna do. You're gonna pretend that it's just a 2x in the front, and you're gonna times that in. Then you're gonna take the negative 1, and you're gonna times that in. So a lot of times I'll say we're taking turns, okay, but it doesn't matter how you wanna think about it. So what is 2x times 3x? 6x what? 6x squared. And now it's 2x's turn to times by the 5. What is 2x times 5? 10 regular x, very good. And then I'm going to move to the minus 1. Now it's that number's turn to distribute. What is minus 1 times 3x?
Yeah.
Okay, negative 3x. And remember what's happening. The negative 1 times 3 becomes a negative 3. And I only had the 1x from this term. Negative 1 times 5. Negative 5. Then after you multiply and you get the negative 5, you're going to look for any like terms. So looking at those, do you see any? Which 2? Okay, what is 10x minus 3x? 7x. Yes, very good. I actually was going to show you that on the next example. Okay, for number 9. Okay, you also, especially if one of them has 3 terms in it, you can do a method that you probably saw in Algebra 2. Okay, it is the same as the arrows. It's just if you like it better or not. So I'm going to show it to you. If you hate it, never do it again. It's totally fine. Okay, the box method is where you're going to put 2x minus 3 this way. Okay, that's going to be this one. And then you're going to put the other expression across the top. So it would be x squared plus 3x minus 5. Okay, and then I want you to make it as many boxes long and as many boxes tall as your pieces are. So I have 2 boxes up and down, 3 boxes across. Okay, and then instead of having to keep track of a million little arrows, you can just times the row by the column and put it in the box. So if I'm doing the first one, what number goes here? What number? 1, right? Okay, so now we're gonna multiply that row with that column. So what's 2 times 1? 2. And then what's x times x2? X cubed or x3, very good. Okay, then I'm gonna take the 2x and I'm gonna times it by the 3x. What's 2 times 3? 6x what? Okay, guys, are we ready?
6x squared.
6x squared is correct. Okay, then last one, 2x times -5 gives me what here? Negative 10x, very good. Okay, and then I can go to my bottom row. Now I'm timesing in a -3, but I'll do it by each one. -3 times x squared becomes a -3x squared. -3 times 3x gives me what here? Negative 9x. And then last one, be careful, if you times 2 negatives, what do you get here?
15.
Plus 15. Okay, then for your final answer, usually you'll notice that your like terms end up in diagonals with each other. So my 2x cubed can't go with anybody. But I notice I have 2 terms with a squared on them. I have a 6 and a take away 3. What is 6 take away 3? 3x squared. And then I have a -10 and a -9. You borrow $9 from me, then you borrow 10 more. -19x. And then plus 15. Okay. So if you like the box method and it's more organized, that's perfect. Do it. Okay, if you don't like it, you can do the arrows. Go ahead and turn the page. Almost done. Okay, if you get a term that is squared, how many times does that mean that you should write it? Twice. Okay, so if you have a squared, you are just going to write that term twice. So let's say, for example, that I wanted to work number 11. My x minus 6 has a squared on it. That means that I have x minus 6 twice. And then I would just look at that and multiply. You can either do box method, put one of them this way, one of them this way, or you can do arrows. I'm going to do arrows. So x times x is what? Okay, x squared is correct. What about x times -6? Very good. Okay, then, now that the x is done, I move to my -6, and it's that one's turn. We are multiplying. -6 times x is another -6x. And now for the last one, careful, it's a -6 times another -6. Very good. Okay, then your middle two, usually they're going to go together. If you borrow $6 and then borrow 6 more, how much do you owe me now? 12. Okay, just like that. Okay, do you feel like you can do that? Doing okay? Not too bad. Good. All right, let's go to number 15. Okay, difference of squares is when you have almost the same parentheses. Okay, but one of them's a plus and one of them's a minus. Let's see what happens. Maybe you remember from algebra 2, maybe not. Okay, let's do 14. Okay, so let's do the 3x first. What is 3x times 3x again? Very good. Okay, then I'm going to do 3x times -5. Minus 15x, very good. Okay, we've times the 3x in. Now it's the plus 5's turn. What's plus 5 times 3x? Okay. And then what's plus 5 times -5? Very good. Okay, then I go to combine. Remember, usually my middle two terms are the same type, but what's going to happen if I have a negative and a positive 15 and I'm adding? They're going to cancel out. So these two right here cross out, then my answer is 9x squared minus 25. Okay, And so anytime that your parentheses are identical, except for one's a plus and one's a minus, that should always happen. Okay? All right, try 15 for me, please. Yes. Hey, try 15 for me, please, and then we'll check it. And then what is 5 times minus and remember that's like a minus 1. So it's 5 times -1. And then just beat the x squared. X squared, huh? Okay, then, so now you've done your 5 into the first term and into the second term. And now it's this one's term. So what's plus x times 5? 5x squared. And then for your last one, you do x squared and negative. So it's a plus 1 and a minus 2. Plus 1 times minus squared. You're multiplying.
Oh.
So 1 times 1 is 1. But since they're opposite signs, they have minus 1.
Okay.
Minus 1, and then you have an x squared. Another
You know what? I'm gonna.
Wait.
Because
Oh, we were adding that, so I thought.
Yes.
Anyway, it's hard to tell without.
Yeah.
One.
okay, let's just check your work real quick. You should have gotten 25 for your first term. Negative 5x squared for your second term. Then you should have gotten a plus 5x squared. And then you should have gotten a minus what? X to the 4. Very good. Okay, then from there, what are my middle two numbers gonna do? One's a plus, one's a minus, then your final answer is 25 minus x4. Okay, so notice that earlier you may not have heard Nate's question, but it won't always count down where you don't have any skips. This one, I don't have any regular x's, that's okay. Questions on that?
Yeah.
No? Okay. Last thing I want to point out, we're not going to do this one, but the pro tip is that multiplication is commutative. And here's what that means. If you have to multiply something long by something short, you can put the shorter one in front and the longer one in the back. Now, for this size, I would probably do box method. So will you go ahead and just show me that you know how to set it up? We're going to put x minus 3 down the side. And then we're going to put x squared plus 5x minus 2 across the top. Okay, but remember that if you decide that you like box method, you are multiplying to put what goes in that box. Don't forget to combine your diagonals. So what would this first box be? X3, x cubed, good. Okay, what would the next box be across the top? 5x squared. Last box on top would be negative 2x. And then last one, now we're timesing the negative 3. So it'd be minus 3x squared minus 15x. What about the last box?
6.
Minus 6? Positive 6. Okay, then I'm going to put here combine like terms. We're not going to finish it, but hopefully you get the idea. Okay. The last one that I want you to look at, and I'm gonna come pass out your notes, is I want you to go back to the one we skipped, number 7. Okay, and I want you to look at that one and just think about it while I pass out your review, then we're gonna do it. Okay, number 7. Okay, look at that one. Okay, tell me on number 7, what do you think you should do first? Should you multiply the 2x in, or should you look for like terms?
Like that. Oh, wait, there's two.
Okay. M dots, right? M means multiply first. Okay, you're not gonna add or subtract until after you multiply. Then it becomes another question, where do I times the 2x into? Okay, why the second parentheses? That is correct. Okay, good. So for that one, let's finish it out. Okay, that's your review. We're gonna do it in a second. That's like your homework. You don't have a Delta math today. Okay. So my front one, I'm gonna keep exactly the same. Okay, why am I keeping it the same? Because there's nothing in front. 10x4 minus 6x3. Okay, but then as soon as I see something to distribute, I have to do it. So I'm going to circle the negative 2x in the front, and I'm going to times that in. What is negative 2x times 5x3? Let's do the numbers first. Negative 2 times 5 is what?
10.
X how many? 4 is correct. Because I have 1 on the outside adding to the 3 on the inside. Next term. Negative 2x times negative x squared. 2x cubed is correct. Or if you call it x3, that's fine. It's the same thing. Okay, next one. Negative 2x times negative 4x. Plus or minus on the 8? Plus. And then last one, negative 2x times 2 becomes 4x. And then once you have all your terms listed, you're just looking to see who can go together. Who can I add together? Okay, so do you see anyone for the x4 to go with? It is going to cancel out very good because you have a plus 10 here, a minus 10 here. And remember the same numbers. Okay, that's going to cross out because one's a plus, one's a minus. What about negative 6x3 and plus 2x3? Should be negative 4 because if you owe me $6 and you only pay me back 2, you still owe me 4. Okay, then I have an 8x squared, nothing to go with, and a minus 4x, nothing to go with. And that would be your answer. Okay, so here's what I want you to do. You do not have a Delta math today. Okay, we are going to do a few of these examples together, but for right now, I want you to just do this back part. Okay, because it's over what we just covered. So will you do the right hand side for me? Number 19. Huh? Oh, it's okay. Okay, you're gonna do 19, 21, and 23. As you're doing it, I'm gonna come around, ask me if you need help. Okay, but do these first.
Why are you getting software updates from Apple when your laptop is moving?
I don't, because one time I downloaded iTunes trying to back up my phone, and now it just will never stop. Yes, we just take the pass. Okay, try 19, 21, and 23. Just do the right column, yeah. Okay, and then if you finish those, go ahead and just keep working. Okay, but your homework is not online, it's just that paper.
Yeah, I'm still lost.
Okay, so you're doing 19?
Yeah.
Is it a
I think
plus?
I'm better.
Okay, Is it a plus or a minus? We have to distribute the minus.
Yes, how do we do?
If it's a minus, you do from the notes.
Okay.
So your first parentheses, the 2x squared stuff, is there anything in front of that? And you're gonna keep that the same. It'll still be 2x squared minus 4x plus 7. Okay, but then as soon as you hit that subtraction, we're gonna push that in, so it'll be minus on another minus 2x squared, it's gonna go to what?
Plus.
On another minus. Makes it a plus 2x squared. Okay, what's it gonna go on next, Oliver? Negative onto what? Negative 3x. And then your last one is another negative onto a negative plus 7. You gotta now look and see if anything can combine. So I have a 2x squared, are there any other x squareds?
Yeah.
Okay, how many more? What's the number in front of it though? Okay, so you have a 2 and then another 2, how many is that? We're adding.
Oh, you four.
What's the x squared? Okay, next we're looking at our regular.
Wait, why don't we add the exponent? When do we add the?
You only add the exponents when you multiply. For multiplying, you times the numbers in the front together and you add it. Okay, so next one, I'm looking for another negative.
Oh, we're not distributing.
Correct. So what's negative 4x and negative 3x? Borrow $4, you borrow 3 more. How many do you owe me now? So I'm not a negative 7. And then you got 7 and. So how many? That's.
Yeah, so that would be my answer.
And then for 21, I'd probably do box method since it's a 2 by 3, but you can also do the arrows if you like that. Yes, ma'am. Yeah, as soon as she gets back. I think I'm gonna. Hold on. Yes. Okay. What's negative 4? Okay, do negative 4 plus negative 3. This should be negative 7. Because think about it, if you borrow $4 and then you borrow 3 more, now you owe me 7. And then what was your last number? That one should have been x 3 minus 2x squared. What is that number? 13? Put in your calculator, it was a 5 and a negative 8. So 5 plus negative 8. Okay, here's what I want you to think about. If they're the same sign, you're gonna add the numbers and then keep whatever. So like here. See how it was a 4 and a 3? What's 4 plus 3? And they were both negative, so the answer's still negative. Okay, but if that's your multiple.
Oh.
If you borrow from me twice, I don't owe you money, right? So if you're adding, you keep, if it's the same sign, add them together, the answer's the same sign. Now for this one, see how you're in by the opposite sign? Then you subtract. No, we're adding now. You already multiplied to get the box, right? So now that you're looking at the boxes, you're wanting to combine line terms. If it's a negative 8 and a positive 5, you're gonna take the difference and keep the bigger sign. So what's 8 minus 5? 3, and then which one was 3? Negative, so that's how it comes back. Okay, for this one, you're gonna have to write it twice on its. Hey, y'all, let me show you, before you write 23 and do it wrong, how many times are you gonna have to square? 2. So here's what you're gonna do. you're gonna do x plus 3 twice. And then, what are you gonna do? X minus 3 twice. Does that make sense? So look, why can I not just do arrows between these? What's the sign in the middle? Plus. What do we do first? Do we multiply or add first? Multiply. So you're gonna have to multiply these two together first. Multiply these two together. And then once you have all your terms, you're gonna look for like terms across, okay? So just to save you a little bit of time there. Yeah. Okay, then you can go ahead and just do your other column, just so you don't have to take it home. How are you doing over here? Oh, good. Well, that's good. Okay, and then if you want to check your answers for the first two, they're up here. Yes. Almost. You're adding these two. What is 1x squared plus 1 more x squared?
Oh, 2.
2x squared.
Oh.
Remember, you only change the little number if you're multiplied.
Oh, so it's straight.
You did it. The other two, the answers are up there. Minus 1 plus 14, x3 minus. Make sure once you multiply to get the boxes, you're adding these together. So like -8 and 5, I think you times those to get 40, you should be adding.
Yeah.
Does that make sense?
Yep.
And then on the x, the one before that should be -2. It's a,
One number.
was it a 5 and a -8?
Yeah.
Does that make sense? Okay, they're so close. And then the plus 18 notes for. To get x squared, I think you times 15. Yes. We have a little bit of a line, but you can be behind whoever I just.
Okay.
Or actually, you know what, she already got it. It was her. Okay, just to kind of keep you moving, the way reviews are going to work, we'll do some of them together. We're not going to do all of them together. Okay, but then your homework will be to try and fill in the gaps and do the ones that we skip. So will you go to your first page? And we'll just do 2 of these. Let's do number 4 right here. Okay, you have a 2x plus 1 squared minus 3. Which direction will we shift if there's a plus 1 in parentheses? What about a minus 3? Down. So you're going to go to the left 1 and down 3. Left 1, down 3. And then normally you can pick to do this or not. I'm going to do it just in yellow so you can barely see it. But you'd go up 1 and then up 3. Do you remember that? Don't do this though. Just look. That's for your normal U that you connect the dots with, right? What is going to change the shape of that? Do you remember? The 2. Instead of only going up 1 box, I'm going to go up. And instead of only going up 3 boxes, I'm going to go up. Double it. 6. So your U should actually be like this. Up 2. And then up 6. 1, 2, 3, 4, 5, 6. Okay, and so now you can see that compared to your original U, okay, that I'm going to keep here in yellow, okay, you can see that the green one ends up getting a little bit steeper. So do we call that, you're going to circle down here, do we call it a vertical stretch or a vertical compression? Stretch is correct. Okay, for your domain, your parabola goes both ways forever, so it's all real numbers. Okay, but for your range, what is the lowest your parabola can go?
-3,
And how high does it go?
infinity.
So -3 to infinity. Okay, then remember, -3, you give it a box bracket. Okay, because it actually does hit -3, but infinity, you can't actually get to it, so you'd put a parentheses there. Okay, let's do one more. Let's do number 5. Which way are we going to shift for number 5 if I have a +4 in the parenthesis or in the root?
Left.
Then, okay, do it. So to the left 4 and up 1. Hello? Yes. I do have Oliver. Is he going home? Got it. Thank you. Bye. All right, Oliver. Or I guess, yeah, you're going to where?
No.
Oh, to get your driver's license.
Yeah, it's the worst.
Okay.
place.
But then you get to drive after. So fun.
No, the DMV store,
Okay, left 4 up 1.
the worst.
Okay. And then when you take your test, let me just, maybe if you're anxious about this, remember the parent sheet with all the shapes? So I'll have a copy of that you get to use. Okay, so your square root is the hook, up over 1, up over 3. Okay, there is a question that is a hook, just like this one, that asks you to find the domain and range. So can you tell me for the domain for the hook, is it all real numbers? No. How far to the left does your hook reach? -4 till infinity. And then for your range, remember it's lowest to highest. So does my hook go down forever? No, how low does it go? Only till 1. So it'd be 1 to infinity for your range. Okay, then, did this one have a vertical stretch or compression on it? No, so you would not circle either one. So I'm just gonna cross them out. Okay, you're only gonna circle that if there's a number in that position. Okay, last thing I want to remind you of from this section is what does the negative in front do?
Flip it.
Flips it. So your normal x cubed is a squiggle up. This one's gonna squiggle down. So do you remember how to shift it with the +2? Is it up, down, left, or right? Up 2. And then your normal squiggle, okay, I'm gonna draw it in yellow. You don't have to draw it on yours if you don't want to. Is up 1, down 1, arm, arm. Do you remember that shape? Okay, but it's not gonna look like that because there's a negative that's gonna flip it. And what does the 3 do? Instead of only going up 1, how many am I gonna go? 3. So let's draw yours. Ready? Start at your center dot, which is up 2. And you're gonna, instead of going up 1, you're gonna go down 3. And then 1, 2, 3 this way. So your squiggle's upside down like that. Okay? The yellow is the original. That's what the parent function's gonna look like when I give you that sheet. But then you need to know how to like change it. Okay? All right. So I would say a good goal would be to finish a couple more of those. You guys are about to go to lunch. We'll do a couple more examples together when you get back. Okay, but go ahead and keep working for me. Ask me if you need help.
We just not just do like the one guy.
Are you talking about for this one?
Yeah.
So normally it would be 3 in a row diagonal, but because of the 3 here, it stretches it that instead of being 1, 1, 1, it's 3, 3.
Okay.
Does that make sense? That it stretches your number of boxes up and down. So let's look at this one at the bottom here. There's a question just exactly like this on your test, which is Thursday. Okay, and all it asks you to do is to list the changes to the parent graph. So let's say we're doing this one because it has 3 changes. What does the minus in the front do? Flips it. Okay, so for me, I'm gonna shorten that and put Roxa. Okay, and y'all might have seen this in another class, but that means reflect over x-axis. Okay, but if you want to put in your own words, it reflects the graph down, that's fine. Okay, Roxa is just shorter, and it just means you're gonna flip it. Okay, can someone tell me the next change that the -3 would give? To the right 3, very good. Shift right 3, and then what about the -5? Very good. Okay, so that question should be very easy if you did your review. You're gonna look at the numbers, see how it changes the graph. Any questions? All right, go ahead and turn the page. We'll do maybe 2 or 3 of the piecewise graphs, and then you'll just have some time to work. Next one, let's do one that has an absolute value bar. Let's do number 12. Okay, number 12. Okay, first thing I want you to look at is the shape of the graph. If you haven't already gotten your parent functions sheet out, you could do that now. Okay, but since we're doing examples together, I'm gonna tell you this is a V shape. Which way does it shift? To the left 3, and then what does the 1/2 do?
Rise up.
Very good. So I'm gonna put it's the rise over run of a 1/2. Okay, but that also is called a vertical compression. You're exactly right. So from that spot at -3, I want you to go up 1/2, up 1/2, up 1/2. And then up 1/2 the other way, just like this. Okay, then from there, you're only gonna connect the dots when that piece is active, which is x is less than 5 or to the left of 5. So if your 5 dot is here, you're only gonna connect the dots bloop, bloop, okay? Just like that, here, and then here. And notice to the left, it's gonna go on forever and ever and ever, because every number to the left of 5 is on that side. What type of circle will this one get? Open is correct. So put an open circle right there. And now we're ready to do the second piece. Your second equation is 2x minus 5. Okay, 2x minus 5 is going to be a straight line. Where is it going to start? Which one? -5. And then 2 is the what? Rise over run, right? So I'm going to start down here at -5. And I'm going to go up 2/1, up 2/1, up 2/1. Okay, so 2/1. 1, 2/1, 2/1. Okay, now notice I'm doing my dots in a highlighter because I'm not going to pick all of them, right? Where am I going to start connecting the dots? Only from 5 to the right. So my 5 dot is right here. You can just barely see it in pink, and then I'm going to connect this way. So my 5 dot is here, and I'm connecting that way. Okay. But notice, maybe I'll make them in yellow so you can only see them. Okay, then all these other dots, I needed them, okay, to get to 5, but then that's why I'm only connecting the dots this way. These don't end up as part of your final graph. Did I do it wrong? You look confused. -5, right, is here. And then 2/1, 2/1, 2/1, 2/1, 2/1, and then my graph picks up. Good? The other thing that is on your test is if it asks you to find, let's say, f of 3, do you remember how to do that?
Yeah.
What would f of 3 be?
3.
I'd have to go up 3 boxes, correct? What about if I wanted f of 5? Do you remember which one of these I would pick?
5.
You'd have to pick closed circle at 5, correct? Okay. All right, let's do maybe one more piece wise. Turn to the next page. I think you have maybe 4 more. Do y'all want to pick one or do you want me to pick? Which one? 10 you said? Okay, 10 is fine. 10, do you see that it calls it a step function? Okay, and remember, if it's a step function, it should be flats all the way across. So my first step is going to be at a height of what? 3, and when am I going to use it? Less than -5, right? So I'm going to go to -5 is here and put my step across at 3. What type of circle? Open is correct. Next step is going to be at a height of 7. Where is it going to stay between? -5 to 5. Very good. So -5 is here. I want to be at 7 all the way until 5. What kind of circle? At -5, I want it to be open, but +5 is going to be closed. Okay, remember, you should never have 2 closed circles on top of each other. Otherwise, you wouldn't know which one to pick, right? You can have 2 opens on top, but no 2 closed on top. Okay, last step is what height? 9, and where does it start? 5, and it's going to go to the right forever and ever and ever. Okay, that one is going to be an open circle as well. It'll be like that. Okay, then go ahead and answer your F's while we're looking at this one. You're going to find F of -8, -5, 5, 10. Is any of those going to be an undefined answer? At -5, very good. So if you want to put a little note here, undefined. And then I'm going to put no closed points. Okay, you have to have a closed point to be able to answer F of whatever. Okay. That one was pretty easy. Do we want to do one off the next page and then be done?
Yeah.
One more. What about 13? 15? Okay, 15's fine. All right, let's do 15. Now notice that on 15, you don't see less than or greater thans. You see equal to and not equal to. So remember that if it's an equal to, this is going to be a solo point. And then remember that for not equal to, remember that that means everywhere else. Except not 5. Okay? So let's do the everywhere else except not at 5 part first. Can you tell me what shape that will be? X minus 3 squared. U. My -3 is to the right 3 and then up 1. To the right 3 and then up 1. And then if you pulled out your parent sheet graph, remember it's 1/1, 3/1. Okay, on both sides to make that U shape. So 1/1, 3/1. To make that U shape. Okay, when I connect my dots, remember on this day on the notes, I'd say, don't connect them yet. We have to look at where we're going to skip. We're going to skip 5. So I'm going to go like this, connect the dots, and then skip 5, and then keep going on the other side. So it'll look like this, all the way through till I get to 5. And then how do I show that I'm skipping that dot? I put a nice open circle over that. Just like that. Okay, to show that everywhere else I'm using the U shape, but then at 5, I'm going to place a solo point elsewhere. Where will I put it at? Very good. I'll come out to 5 and then I'll place it at down 2. Okay. All right, last thing. I'm going to send out, since you may not finish this today, I'm gonna send out the answer key via focus messages. Do you know how to check your messages in focus? Okay, if you do, that's wonderful. If you don't, okay, I'm just gonna show you, actually pull up your focus maybe. And I just want to show you what it'll look like when you get into it. Okay, you're gonna have a little icon that looks like this. And it'll come through right here. You'll have a little text blurb. And if you click on that, you'll see a message from me at the end of the day today. Okay, under communication, correct. Okay, so if you click on the little text box thing, this one, okay, then you'll have a message from me with the answers for you to check your work. Okay? So if you need help finding that, let me know. Otherwise, you have the rest of class to work. You have about 12 more minutes.